In this video, we'll be discussing Refsum disease, an autosomal recessive disease resulting in the accumulation of phytanic acid in tissues. We'll give you a visual mnemonic to help you remember the cause, signs, and symptoms of this disease, so you'll be ready to answer any question on test day. All right, let's get started. If you didn't guess this already from the music at the start of our video, our scene takes place in a bullfighting ring. Well, it's really an ox fighting ring, but we'll touch more on that later. First, take a look at our referee here. I wonder why the referee had to step into our ox fight. More on that later, but for now, just know that he's trying really hard to tame the ox. In fact, this referee is here to help anchor you to our scene on Refsum disease, because referee sounds a lot like Refsum. Get it? Referee for Refsum? And what's that in our referee's hand? Yep, that's right, it's a bottle of peroxide. He's using it to treat any wounds our fighters have sustained. I hope nobody got hurt. Anyway, this peroxide bottle is here to help you remember that Refsum disease is a disorder of paroxysms. Refsum disease results from mutations in the PHYH and PEX7 genes. Recall from your class in cell biology that paroxysms are tiny organelles found in all eukaryotic cells, and they're involved in a variety of biochemical reactions, such as the breakdown of very long-chain fatty acids, and more importantly, in Refsum disease, the breakdown of branched-chain fatty acids. Next, take a look at our ox here. He looks pretty angry and aggressive. That's because he's ready to fight with the referee. Anyway, this bullfight, ox fight, is to help you remember that Refsum disease results in the accumulation of phytanic acid. Get it? A fight for phytanic acid? Okay, so what exactly is causing this accumulation of phytanic acid? In Refsum disease, phytanic acid is a branched-chain fatty acid that can't be broken down. Put another way, the alpha oxidation of phytanic acid is impaired, which obviously results in the accumulation of phytanic acid and its derivatives. To help you remember this defect in alpha oxidation, take a look at our ox's horns. Whoa! Our referee really bent those horns back in order to stop the fight. If you look closely, the horns have been turned all the way into an alpha shape. And as you probably already know by now, these alpha-shaped ox horns are here to represent alpha oxidation, which, as we mentioned earlier, is impaired in Refsum disease. Anyway, just remember our alpha ox's horns here to remember the impaired alpha oxidation of the branched-chain fatty acid, phytanic acid. Before we move on, I also want to briefly mention one of the genes commonly mutated in Refsum disease. Remember back when I said that the disease can be caused by mutations in the PHYH gene? Well, PHYH stands for phytanyl-CoA hydroxylase, which is involved in the alpha oxidation of phytanic acid. Now, you don't need to remember that whole enzyme's name, but you should remember that the PHY in PHYH is related to phytanic acid. This is just an extra memory hook that should help you remember one of the causative mutations. Next, turn your attention to the priest on the left of this image. This priest represents pristanic acid. Get it? Priest for pristanic acid or prestanic acid. Anyway, this priest is blessing the bullfight and represents the body's inability to metabolize phytanic acid to pristanic acid. He's far away from the ox, which means he can't be harmed. Or in this case, he can't be formed from phytanic acid. Anyway, just remember this priest here, and you'll know that pristanic acid isn't formed. Now that we've gone through the molecular basis for Refsum disease, let's review its symptoms. Take a look at our dizzy matador. He's about to fall over from his dizziness. The dizziness is here to help you remember that Refsum disease causes ataxia. The body's inability to metabolize its long-chain fatty acids impairs central nervous system myelination. This results in a number of neurological defects, such as the ataxia pictured here. Next, notice that our matador is blindfolded. At Pixorize, blindfolds are often used to symbolize visual defects and abnormalities. So naturally, This Matador's blindfold is here to help you remember that Refsum disease results in vision loss. More specifically, these eye problems include cataracts and retinitis pigmentosa. Next, notice that our matador is holding up a bone club. I thought matadors had swords or something, but I guess a club will do. Anyway, the end is chipped and it looks like it's falling apart. This bone club is here to help you recall that Refsum disease can also cause bone abnormalities, such as epiphyseal dysplasia. Recall that long bones are divided into the epiphysis, metaphysis, and diaphysis. The epiphysis is the rounded end of the long bone, so it should make sense why the end of our matador's bone club is messed up. You might even say his bone's epiphysis is dysplastic. Next, notice how our matador seems to have stubbed his toe. I guess our matador here got a little too cocky with the blindfold. As soon as the blindfold goes on, he hurts himself, and now the referee has to stop the fight. I also guess that's what the peroxide is for. A stubbed toe? Lame. Anyway, this matador's stubbed toe should help you remember shortening of the fourth toe, which is another sign seen in Refsum. First, epiphyseal dysplasia and now toe shortening. Talk about bone problems. Next, notice our matador's snakeskin boots. Doesn't every good matador have fancy boots? Or am I thinking of cowboys? Either way, these scaly snakeskin boots represent ichthyosis, which refers to a group of disorders characterized by scaly, itchy skin. Next, take a look at the small snack cart behind our matador. At Pixarize, we symbolize autosomal recessive disorders with small, recessive, automobile-like vehicles like snack carts, and autosomal dominant disorders with really big, dominant automobiles. This small snack cart is here to help you remember that Refsum disease is an autosomal recessive disorder. So how do you treat Refsum disease? Well, since the disease is caused by the body's inability to metabolize phytanic acid to pristanic acid, it makes logical sense to treat the disease by minimizing dietary intake of phytanic acid. This works well because phytanic acid isn't produced endogenously. In other words, it isn't produced by the body and must be taken in by the diet. Long story short, Refsum patients should just avoid eating phytanic acid. Alternatively, another way to treat Refsum disease is to go in and actually remove the phytanic acid. That's right, I'm talking about plasmapheresis. In plasmapheresis, the patient's plasma is removed from the body, the phytanic acid is taken out, and then the plasma is returned or exchanged. To help you remember plasmapheresis, our priest here has a plasma ball. Get it? Plasma ball for plasmapheresis? These ancient priests always have magical powers, right? I guess conjuring up plasma balls shouldn't come as much of a surprise. So that wraps up our video on Refsum disease. Let's do a quick recap. Refsum disease is an autosomal recessive disorder that results in the body's inability to metabolize phytanic acid to pristanic acid. This defect in metabolism is caused by a defect in the peroxisomal alpha oxidation of branched-chain fatty acids, specifically phytanic acid. Signs and symptoms include scaly and itchy skin, vision loss, ataxia, epiphyseal dysplasia, and shortening of the fourth toe. Treatment for Refsum disease includes dietary modifications to exclude phytanic acid from the diet and plasmapheresis to actually remove phytanic acid. Thanks for joining us for our discussion on Refsum disease. We hope to see you for our next video.